Hello, I'm Daniel Gregoire. I've recently released a couple of open source libraries with the goal of helping Clojure developers use Clojure metadata more effectively. The primary library is called Metazoa, and you can find it on GitLab under the group Glossa. So if we look at the README, at the top of the README, there is dependency information as to how to pull in this into your own projects. And there's also a list of exclusions of optional dependencies that are included by default so that you have the full power of the library. But if you don't plan to use pretty formatting or the data script functionality or the validation that Mali schemas give or the full text search that uses Lucene, then you can exclude any one of these dependencies to make the library load more quickly. All right. We're going to learn how to use this at the REPL because Metazoa is designed first and foremost as an interactive tool for development. So we're going to go ahead and just create ourselves a new project. I'm going to go into the place where I keep my Clojure projects, and I'm going to make a brand new project called Learn Meta. And we'll go into there, and we'll give ourselves an empty depseeden file. We'll make source and test directories, and we'll get an initial source file called Learn Meta. Now, I've used Emacs for many years, and this year I've been using NeoVim exclusively, but just to show that this library is not in any way editor-specific, I'm going to be doing this demo in Visual Studio Code. Let's go ahead and open up Visual Studio Code and get this rolling. So we're going to need... it's got old stuff. All right, here we go. We need dependencies. The dependency will pull from the README. It's going to be dev.glossa/metazoa, and I'll use the Maven one for now. They're both equivalent. Paste that in. Now we have a legitimate depseeden file, and then we'll go to Learn Meta, and we'll go ahead and add in here a requirement for this library. It's Glossa Metazoa, and I'm going to alias it as Meta. All right. So with those two things in place, I'm going to go ahead and ask Calva to jack in, and we'll use depseeden. So on the right-hand side, we see the REPL output. On the bottom, we see how Calva is starting our REPL server. Close that for now. Okay. So we are now inside of a REPL. I'm not going to go through how Calva works, but it has a nice intro REPL experience. All right, so if we look at the README for Metazoa, we'll see here that there's a help function that we can invoke to see how to use this library. Let's go ahead and do that. So if I were to invoke that, I get a stack trace because I haven't loaded the file yet. I'm going to go ahead and load the file without that in place. So we'll do the magic of loading the file. And it's going to pull in, it's going to evaluate all the Clojure code in the Metazoa library, and of course pull in the dependencies that are, not pull in, but evaluate the code for the dependencies. All right, so with that in place, we can now do meta help. And we see some things printed out at the REPL over here. Welcome to Metazoa, where metadata comes to life. It's prompting us to try out the tutorial by invoking this. All right, let's go ahead and give that a shot. We're already seeing some interesting things. This looks like it could be Markdown, given the fenced code block, but it stops being Markdown when it gets to the code and renders that inline so that I can easily evaluate this code while at the REPL. So I'm going to go ahead and call the view function and pass in a symbol representing a namespace, and I'm going to pass in this qualified keyword, Glossa Metazoa/tutorial. So we're going to be viewing Glossa Metazoa's tutorial. All right, let's go ahead and evaluate that and see what happens. All right, we are now inside of an interactive REPL, and an interactive tutorial. There appear to be 6 steps in this tutorial, and we're on the first one. Everything's in Markdown except when when we get to code, and that is rendered without comments here so that I can evaluate it myself. This particular example has been pre-evaluated for us. If I look at all the metadata on the Glossa Metazoa namespace, I find these 4 entries. A classic Clojure doc, and then 3 Metazoa specific metadata entries. This tutorial player has a few helpful functions, and it puts you into a custom namespace that you, the tutorial author, define, and then it adds a bunch of functions that are specific to the player into the namespace, all of which begin and end with a pipe character in the hopes that that will not conflict with any functions that you want to add to your own tutorial namespace. So if I go ahead and just type that, I can see all these different ones that are part of the tutorial player, but at the end of each step, the tutorial player returns for you a data structure that includes the main controls that I expect you'd want to use. So we're going to go ahead and move on to the next step here by evaluating this right arrow function. All right, step 2. The primary use case for Metazoa that I initially wanted to support was simply viewing rich metadata. Metadata is that place where we are adding data and coming close to providing information to other human beings. And information naturally needs to be represented in various ways specific to the context. Here I'm going to show just some very simple examples to give you a sense of what you can do in the hopes that you then are inspired to do things more interesting with your own code bases. If I don't know what rich metadata I might find on a Clojure var or a Clojure namespace, or anything that can contain metadata. In Clojure, anything that can contain metadata is an instance of Clojure lang imeta. So I call them imetas. If I don't know what metadata is on this var, of course I can call the Clojure core function meta and see all the metadata on the var. But Metazoa provides a set of multi-methods and functions that allow you to opt into Metazoa's API for viewing and checking and testing and querying for and searching for metadata entries. And so MetaView allows you to see which of the metadata entries on the imeta participate in any of Metazoa's multi-methods. So we'll go ahead and evaluate this first one to see which what we call metadata providers are in the metadata map of the max var. Okay, so I evaluated this line here, 73, and I see that there is a Metazoa example and a Metazoa function table on this var. So we're going to go ahead and look at the function table first. What could a function table be? Okay, the Clojure's max function, of course, gives you the maximum of the numbers that you pass to it. But if you limit the arguments that you pass to max to 0 and 1, then you can also treat max as logical OR. So max of 0 and 0 is 0, but max of 0 and 1 of any other value is going to be 1. So this is just a nice rendering of a function table that demonstrates the behavior of the max function across a small but interesting domain. The next metadata provider that's on this var is a executable example, just called a meta example. If I were to evaluate this, I'm going to get an interesting rendering of one example usage of the function in play. So this is max with 4 arguments passed to it, and then an indication that if I were to evaluate that, I would get this value. Okay, interesting so far. So if I go to the trouble of adorning the max var with a function table specification or executable examples, then I'm going to be able to view those things at the REPL. What does it look like to have defined that metadata? We can take a look at that. Let's go ahead and pull off the fun table value from the metadata that resides on the Clojure's max var that I added. Obviously, this is not built into Clojure. We're able to add metadata to existing imetas anywhere on the class path. So in Metazoa, I've added these small examples for the purpose of the tutorial. So a specification for a function table has you specify a sequence of left-hand arguments to give to the function and right-hand arguments to give to the function, and then an optional label. So in this case, it could have been max, but or indicates kind of the intent of the table. So why left hand and right hand? Well, the table has a set of axes, and there's only two of them. So to make it clear how the table will be organized, you can provide left-hand args and right-hand args. If you need to provide more than one Clojure value, if you say your function takes 3 arguments and you want to do a table that has the left-hand arguments involving 2 of those 3 and then the right-hand just involving 1, then you simply have to pass nested sequences here. And we can see examples of that. And then for the example, what does the example look like? So if I change fun table to example, what does that look like? Okay, so in order to put an example on an iMeta, I provided a code entry with a quoted form representing the Clojure code. You can also provide a string because these are also rendered at the REPL. And if you want to have very specific rendering of your code, you can pre-stringify it. There's also the option to add pretty or format Boolean entries to this map, and Metazoa will automatically call Clojure core Clojure pretty print on your code example, and or apply CLJ formatting if you keep that optional dependency on the class path. Here I also specify the expected ahead of time, and this is going to lead us into the next step of the tutorial, whereby if I'm going to be writing out executable examples, I want to make sure that I can test that over time my executable examples are still valid in case I go and change the behavior of a function. Finally, we do specify the namespace in which a given example is meant to be evaluated. This one is trivial in that it uses only Clojure core forms, so it should be good in any valid Clojure namespace. But if you're building out executable examples in a more complex namespace with multiple namespace aliases, you want to make sure that it's clear in what context the executable example should be evaluated. Okay, with all of that, how do I get to the next lesson? I see my controls are still up here. If I had forgotten how to go forward, I can also invoke the help function that's for the tutorial player and get an explanation of the controls again. So we'll go ahead and just use this one here to go to the next lesson, next step in the tutorial. All right, here we're at step 3 of 6. This gets into the piece we just hinted at about checking and testing your metadata. If you're going to spend time adorning your iMetas with your namespaces and your vars with rich metadata, then it makes sense to ensure they stay as fresh as possible. And one of the only ways that we as engineers have of doing that is making our test suites fail when our expectations no longer hold. So Metazoa provides a whole story for checking that your metadata providers still work the way that you expect. Metazoa has these built-in metadata providers. We've already seen the function table. We've seen the executable example. We have been using this whole time a tutorial, and we'll later look at doc, which is kind of the most powerful metadata provider of them all. If you have metadata that it resides at these keywords or that has its type adorned with this keyword, and you can see examples of that in the README, then it makes sense to implement also Metazoa's check metadata multi-method. And by implementing that, you're able to exercise instances of your metadata provider and also to test them. Metazoa only provides built-in support for Clojure test, but that's why there's a separate check, and a separate test story. The check story returns just a data structure representing whether or not, just in the case of executable examples, evaluating the code and showing the expected. So here we'll see that we saw before what our code and expected looked like for the max var. Well, here we're calling check on that max var and looking at the example. And when I call check on an iMeta and I provide a key, I get back a sequence of all the checks that were done for that data. So here was my code, here was my expected, here is what it actually evaluated to, so it's still passing. And I also include the output, the standard out and the standard error in cases where you need to test what's being printed. So this allows you, in a test framework agnostic way, to get a data structure representing what happened when this particular value on this particular var, in the metadata of that var, was exercised. When you actually need to test, call Clojure.test is and have an assertion, then there are a couple of things that you're able to do. Metazoa has built-in test imeta or test imetas, where you can pass in specific imetas and test all of the metadata providers that are found on those vars. But you can also just invoke test imetas with no arguments, and if you do that, it will test every imeta that it can find on the class path. So this is a way to exercise all of them if you don't want to specify specific vars. If you use Metazoa enough and you have a lot of different metadata on a lot of different namespaces and vars, I highly recommend that you do this. This gives you testing for free as long as you also encode things like expected values in your examples. You're not required to. You don't have to provide an expected. You can just have a code entry. But then you don't get the benefit of true testing. In that case, this particular metadata provider will just exercise the code and ensure that it doesn't throw an exception. All right, so that's checking. Highly recommend that you give it a look-see, and the built-in metadata providers all provide a check implementation, so you can see how that's done. All right, let's go ahead and move on to the next lesson. Alrighty, this step introduces us to the metadata provider, and that is the Metazoa doc. Built-in doc strings are just that, they're strings, and a string is fairly opaque as to what's inside it, and it's very easy for that string to become stale, because it's usually just natural language and some indication about the function's arguments and its return value. More often than not, what we really need is a combination of natural language prose, executable examples, if it makes sense, a function table, if it makes sense, other visualizations that help describe the function or describe the namespace. And we really shouldn't be limited to just a string. There are many different environments in Clojure's ecosystem for notebooks and mixtures of Clojure code and data and natural language prose. The one that I prefer to use most often is basically a Clojure tree structure for a document. That you'll see here a syntax that looks very much like Hiccup's syntax for writing HTML. But this is backed by a library that I've released called Weave. It's also under the Glossa group on GitLab. And it allows you to write Hiccup-like vector of vectors to define a tree structure for your document. It accepts most of the most common tags that are defined in HTML, but its default output is Markdown. And the reason that I use Weave is I want to have the ability for Metazoa and others who want to extend Metazoa to have the ability to extend this document format and to support the metadata providers. So this particular document, you can see, has embedded into it a meta example, a Metazoa example, and a Metazoa function table. You'll see these are actually the same specifications that we saw before attached to the max var. In this case, this is min, but attached to the max var we saw. But these are inline in my document. So things that look like standard HTML markup are going to come through as the equivalent markdown, a paragraph or ordered list, unordered list, description lists, etc. But if it encounters an entry that has a metadata providers keyword as the tag, then all of a sudden we treat this as a custom node in the document tree and do the right thing for that particular metadata provider. So in the case of an example, this one's going to go ahead and render this code in the document, and it's going to pre-evaluate it and show the evaluation. I have lots of different, there's a handful of different configuration options available on these. I could also have added eval question mark of false to prevent automatic evaluation. That's what a lot of this tutorial uses. So examples in the tutorial where you don't see these hash underscore arrows, those are places where eval false was set for that particular executable example. So why is this important? You may want to adorn a var or a namespace with just one or two metadata provider entries, maybe just an executable example, because you can define not just one executable example, but you can define many executable examples in one example entry. This accepts both a single map and a sequence of maps where as many examples as you want can be added. But what we really want is the ability to weave together, hence the name of that library, weave together description of what we're trying to accomplish, context, intent, with executable examples, visualizations. And so to accommodate that, we really need a document. We need an artifact that is meant to synthesize and convey information. So any metadata provider that you define, I also encourage you to extend weave, and you can look in the Metazoa library to see examples of the handful of expressions that had to be written to add support to weave for this metadata provider and for this metadata provider. They basically rely on the Metazoa render functions that you're already going to write if you have your own custom metadata provider. So what does it look like? Well, it looks like this tutorial. In that this tutorial is written as a sequence of steps. Each step is a Metazoa doc value. It's a weave document that gets rendered to, in this case, markdown in the REPL with these leading comment marks and with code being rendered without any leading comments. You also have the ability to write just a standalone Metazoa doc. And when you do that, you can view it in the REPL if you want. You can also render it and write that rendering to a file. And all of a sudden, you have documentation generated from the metadata of your project. Is actually how the README of Metazoa itself is generated. It's all a big Metazoa doc that resides on the Glossa Metazoa namespace. And just to give a little bit of shock factor to the REPL experience here, we'll go ahead and look at that document for a moment. So this is the namespace, Metazoa. And if we take the metadata from that, and we then take the Glossa Metazoa doc value from that, then we will see a large tree that thankfully Calva does not pretty print. I wonder if I can get Calva to pretty print that. Here we go. So this is a non-trivial weave document that is used as the Metazoa doc metadata value that resides on the Glossa Metazoa namespace. So if you need a good example, this is at least a fairly complete example of what it looks like with various kinds of executable examples and inline code and yeah, full description of the library in addition to all that. All right, let's continue. I'm going to refresh the lesson so that I can see what we missed, if anything. Yep, and we did. We can look at this particular one too. This is a much smaller doc, but you can see in the doc here, I put together both an executable example and the function table. So it's a much smaller example of a Metazoa doc. All right, let's move on to the next lesson. All right, so We've seen how to view metadata. We've seen that we are able to check and test entries that are metadata providers that participate in the Metazoa multi-methods. But how do I discover what vars and what namespaces might have this rich metadata? Or how might I just search through my own metadata that maybe doesn't participate in the Metazoa multi-methods? Well, for that, there are two facilities that Metazoa provides. One is a full text search experience that depends upon Lucene, and the other is a querying experience that depends upon DataScript using Datalog queries. I'm going to show first the full text search, and that it might be the easiest to try out if you're not familiar with Datalog and DataScript. Right, so Meta has a search function. If you pass it a string, that's just a simple word or set of words, it will, by default, immediately index all of the iMetas that it can find on the class path. This includes namespaces and vars primarily, but you're able to pass to the search indexer any iMetas that you want, so you could have your own set. Anyway, when you pass a string here, it's going to index all of those iMetas, and then it's going to perform a search across pretty much all of the fields of all of the entries of metadata on the class path. And it tries to include all of them, and this ends up setting a multi-field query for Lucene to search for the word source. So let's go ahead and evaluate this. And we're going to watch for some printing, indexing metadata, and then here is a set of all of the things that it found. You'll notice that by default, Lucene prefers well, anyway, I won't go into the Lucene scoring methods, but here's a set of results for that search. If you want to limit how many come back, you can have your query be a map and have 2 entries of query and num hits or limit, and that will limit the number of results. But you also have full access to all of the fields of metadata reified as document fields in Lucene. So you can look at the Lucene namespace in Metazoa for more details if you're interested, but basically any of the entries in your metadata are added, all of them are added as fields in the document with a little transformation done so that the syntax of what was keywords in your metadata is now legal document field names in Lucene. But here I'm looking for source. I'm excluding all namespaces that begin with citer, and I don't want to see any forms that are macros that have the macro metadata set to true. So here's a smaller set of results that include just those, no citer dependencies in cite, even though here that's not an issue, but it definitely was an issue when developing in NeoVim. All right, and then finally, you'll notice that I'm returning not Lucene documents, but iMetas, and these are all looking like functions or just plain data on a var. But I can also specifically pull in iMetas of certain types. So Metazoa adds a few special fields, and this is one of them. You can see actually down below that these 3 are added. So I can specify that the types I want to limit myself to are in fact namespaces. So here, give me all of the namespaces whose names basically begin with Clojure. So here we'll get a list of all of the Clojure namespaces. So that's really powerful. Best suited for really the open-ended queries where maybe you're not sure where to find something. This is like a more powerful apropos that's available under the Clojure REPL namespace. All right, with searching out of the way, let's go ahead and proceed to the next lesson and look at querying. All right, so if you know more of what you're looking for, or at least if you know the structure that you're looking for, then query is going to be a more powerful interface than the search. You're not at the mercy of the scoring. You can just specify exactly what you want. So here are a few examples of using queries. You'll notice this is just Datalog queries that DataScript supports. I've gone to the trouble here of just a little bit of ergonomics. There's a Datalog database in the background. You don't have to specify it, but you can if you want to. And here I'm going to look for, show me all of the names of iMetas that have the following namespace that I pass in, and that have an added metadata entry that is one of the ones I'm passing in. So I'm passing in the namespace that is Clojure core. You'll notice it's the namespace. It's not the symbol, it's the actual namespace value. This is data script, so everything's in memory. I can use any Clojure value that I want. And then I'm looking through Clojure versions 1.5 through 1.7. So if I do that, I see all of these really interesting and powerful tools that were added to Clojure in those versions. Pretty cool. How many of my public vars are lacking a doc string? So this is everything on the class path. By default, it's actually everything that's a public var. It doesn't include private vars by default. Again, you can pass your own set of imetas to this indexing functionality to have everything included. But by default, it's just the public vars. So how many don't have a doc string? All right, there are over 1,000 that don't have a doc string. I could go further and say, okay, perhaps I don't care if like simple like magic numbers that I've added don't have doc strings. Maybe the name of the var is sufficient. But let's go ahead and say, okay, how many things? This is a shorthand for saying the imeta has a namespace. So this is going to limit us to vars. Let's go ahead and say meta, and then let's say imeta right. Here's the value, right? So if it's a var, I also index on your behalf the value and the type of the value that the var is holding. So the imeta, if it's a var, it's going to be the var as a value. But it's tricky to get at the value the var is holding if it's not already pre-indexed, right? So in the DataScript database, you have access to these two attributes, and so I'll say, let me go ahead and bind the imeta value, and I'll just call this the value. That's so if you were like if you were to dereference the var, this is what you would get out. Right? So it's the raw function value, or it's the raw number, or it's the raw string that is being defed. And then I want to say, is that thing a function? So this will limit my query now to say, okay, what are all the public functions that have no doc string? And that's still a very large number, 869. And I could go further and say, okay, how about my code base? I could pass in a prefix. And in Metazoa's README, you see an example of this where we can limit ourselves to say let's see here. I can actually pass in just a function to limit the query to vars whose namespace falls under a certain package level, like all glossa dot namespaces. So anyway, finally, if I am curious about finding certain kinds of metadata on the class path, okay, you said that there's tutorials and executable examples and function tables and Metazoa docs. But where do I find those things? How do I know whether the libraries I've pulled in have any of those defined? Well, that's what you can use this query mechanism for. You can say, give me a series of all the imetas on the class path that have a tutorial defined for them. And so far, there's just this one, which is the one we're already working through. But we can do the same question for executable examples, and there should be a bigger number. Uh-oh. A bug. Oh no. So we can see that my sorting here is not going to work. It's just a bug in this example, not a bug in the actual query. So there's a function called imeta with an example. I've added an example to Clojure core .name, and I've added one to max on the class path. All right. And how about function tables? Same thing, right? You can look for all these. Okay, I have a function table on min, a function table on get, a function table on max. And then, of course, I could go further and look for more than one of those and find all the different entries that have any of those. So that's a way to discover things on the class path. But it's not limited, of course, to Metazoa's metadata. Any of the metadata that's on your vars and namespaces is indexed. So you can make queries that are totally independent of all of this Metazoa-specific functionality. All right. If we're done in this one, go ahead and go to the next, and we're at the end of the tutorial. So I've given you kind of a whirlwind tour of what Metazoa is about and how to use it. Things I did not get into. I did not get into how to actually implement your own Metazoa metadata providers, what the multi-methods are, etc. I hope to put together another video that shows more of how Metazoa is put together and the extensible API that it exposes, as well as perhaps some video content on Weave specifically and how to extend Weave so that when you are writing your own metadata providers, you can also incorporate them into Weave documents effectively. Thank you for your time, and I hope that this becomes a tool to allow us to add metadata that is more pleasant to view in the REPL, that can be rendered effectively into documents, that can be tested and checked automatically, and that is easily discoverable at the REPL via searching and querying. Take care.